Hey everyone. So for today, I've done some research, looked into some specs, and I'm going to have a formal presentation about how JavaScript, or rather ECMAScript, evolved. But to make it more fun, I also have a couple of demos. So I understand that some of you here work with web frontends, right? Is that correct? Anyone? Okay. So how many of you have started working with it in the last year? Okay. Last 5 years? Okay. And anyone who has been working for more than 5 years? Right. Maybe more than 10 years? Okay. So you will understand what I'm talking about then. So let's get on with it. That's me here or there. I work in IT security. I did some programming when I was 7 up to 10. I did some HTML, some PHP, some front end, but I haven't done that for a long time. So I was invited here actually to give you some security context to what you do, because it's important right now. Many developers actually take a look at that and are forced to take a look at that because of all the problems that are happening all around the internet, all around the world, right? We are having more and more script kiddies, more and more targeted attacks. That's because people are moving everything online. So in a couple of years, we won't have any systems that are not connected, where we don't have a version of it online. So, and the first programmers to actually tackle that are the ones who are not doing web development, because web development is, front end, it's all about colors, it's about fun, it's about user experience. It's not that much about security, right? But still, security matters. So I'm going to talk about that. I do own a company called Possible Security. We just celebrated our 5th anniversary this week, was it? Yes, this week, beginning of this week. Great party. And I love hacking and breaking things. If you want to take a look at any of my other presentations, you can go to kirils.org, or if you want to see how we broke, let's say, how we found vulnerability in the local bank, or how we broke the local transportation system, you can go check out all the articles on our webpage. So we're going to quickly walk through some boring but useful stuff. So since you are front-end developers here, and you do work with making sure that the user is happy, with usability, with accessibility, you may have forgotten what security is. So I'm going to start with that. The CIA. It's called. I didn't imagine that. It's actually called the CIA triad. It's one academic way to look at security, and it consists of confidentiality, integrity, and availability, and all those three things together make up security. We also have authenticity and non-repudiation in some academic circles, but it doesn't matter. So these are the important ones, and it's not the kind of triangle where you have to go to one corner to lose the other. You have to have all three sides solid in order for the application to be secure. Good thing is, when working with front end, when you actually secure your application, most of them will get more secure at the same time. But as a front-end developer, you should understand the difference between these. You should work with every aspect, every of these three aspects of the CIA triad. So confidentiality is the easiest one. People who are not in security usually mix it up with security. They just call this thing here security. Well, security are all three things together. Confidentiality is when other people can't get to your stuff. That's a simple version of it, right? And then we have two more which are a bit more complex. Integrity. Integrity means that if you have your stuff there, no one can change it without authorization or without a trace, right? So if you have, let's say, 20,000 euros in your bank account, and if you log in tomorrow, you are still supposed to have 20,000 euros, right? Or if the money is gone, you have to have some reason why the date was changed, right? So that's integrity. And availability. Availability is easier, but a bit more trickier. Availability means the system should be available when it's needed. but only during the specified hours. When I talk about availability, I always mention the state bank. Well, not the state bank, but the bank that's here in Latvia manages the accounts for all the state institutions. They have defined their availability from 8 a.m. to, I think, 10 p.m. And at 10 p.m. they switch off the damn server and it's not available. But it's all fine because that's how they defined it. So you measure availability against the defined times. So that's the security stuff. So CI triad, confidentiality, integrity, and availability. Keep that in mind. Not during this lecture. Keep that in mind when you develop your front ends. Think not only about how your user can lose data, but how can your user lose access to your application, and how can data be destroyed or mangled, not only on the server, not only on the backend, but also as a representation to the user. Even if it's safe on the server, if a user every time they load your application gets wrong data, it's also not a good thing. So there's a thing called JavaScript. You use it, I guess. Anyone doesn't use JavaScript when doing front-end development these days? No. Oh, okay, good. Congrats. Yeah, I personally dislike JavaScript very much because of all the security issues that it brings to the table. So I actually browse without JavaScript, which means that I'm a bad person and nothing works for me. Please do use fallback functionality. You know, now you have possibilities to compile the same JavaScript on server side now and serve it transparently. Please do that. It will help me a lot. That's all I wanted to say, actually. Thank you. But that was one of the reasons why I accepted this invitation to come here. So JavaScript is quite young. Some of you have been working with front-end for more than 10 years. I've been doing different kind of programming, including when we were little, doing some nonsensical stuff with both BASIC on the X spectrum and HTML. In a couple of years later, and JavaScript was just being created. I think I was around 10 years old when JavaScript was created. So it's quite new, right? It's quite a new concept, but it doesn't really matter because in IT everything evolves so fast. We get all these new versions right now, which we're going to talk about in later. So most of you probably will not know that, but it was created by Netscape in 1995. So why is it JavaScript? It's a good question, right? Why is it called JavaScript? It's not Java, really, right? I read this joke on Twitter saying that if you compare Java to JavaScript, you might as well compare. Damn, forgot the joke. I'm gonna give it give it to you later on. Anyway, so it's not super similar. The idea behind the name is actually, so there was this one guy who invented it, who was contracted to do that, because Netscape wanted some to lessen load on their servers. It was all about lessening the load back then. Now it's about giving everything to the user, still lessening the load on the servers. But back then it was really important because the servers were like 40 megahertz, 200 megahertz maybe, machines like that. So the problem with HTML and HTTP back then was that you had to push everything to the server, right? You had to, if you needed to validate a form, you had to pre-push it to the server, refresh the page again, and get the error message that way. So the original reason for JavaScript was actually form validation. That was the main reason why JavaScript was created, form validation. So Netscape was working with Java, with Sun, that owned Java at the time. But the guy that they contracted to develop this functionality wanted the language to be a scripting language, not a statically compiled language, and he wanted to do it in Scheme, which I think is a dialect of not dialect, a derivative of Lisp. So in the end, JavaScript was born because the guy created a new language in 10 days. He wrote the spec, so that's why JavaScript is so terribly insecure. It was created in 10 days. JavaScript was born. Name came from Java. They mangled around with the name for a couple months there, but there you have it. So as you know, it has a C-like or Java-like syntax, however you like to think about that. And what's interesting is it also contained the browser object model and the document object model at the very beginning, which is if you think about it, kind of obvious, right? Because you wouldn't be able to do anything without those. What surprised me when I was doing this research is that same origin policy actually was there in 1995. They created it. Same origin policy, we're going to talk about the current implementation of it in a couple of minutes. But it basically says that using your JavaScript, you should only be able to access the document object model of the pages that are open on the same protocol host and port at the same time. Which is kind of good if you think about that, but then hackers found a way, and it didn't apply to BOM at that time. So then there was JavaScript. Nowadays, if we talk about JavaScript, we understand this Microsoft server-side language that is kind of basically the same as JavaScript, but it's living server-side. Back then, it was just an alternative to JavaScript. So Microsoft created a clone. It's called JavaScript, and Netscape feels that their feet are burning and try to push standardization really quickly. Because we all, well, some of you who are old enough remember what happens with the web if we don't standardize it. Then we have monopolies pushing strange things. And the same is actually happening right now, right? As security specialist, I may support some of those changes. But for example, the push for HTTPS-only web, right? It's kind of good, but there are drawbacks. As if you talk about vulnerability surface. And it's being pushed just by some large market players. It's not a consensus. So we are back where we started, actually. But back then, a bit after that, basically Microsoft was doing whatever they wanted with the Internet Explorer. So Netscape decided we need to push for standardization. So that's when ECMA 262 was created. It's a standard. It basically said, well, what we did there in 1995, that's good, let's do it like that. So that's all it was. They published it and expected people, well, browser manufacturers to use it. In 1997, ECMAScript version 1 was published. Finally, in 1998, ECMAScript number 2 was published. It's just a formal change that changed the description of the language, not actual functionality. Also, we got a first official document object model level 1 specification that year. So developers could finally start doing something useful cross-browser without having lots of code. But you still needed to have lots of code to manage the browser object model, and it's much better this year, but still a challenge. So right, we have ECMAScript 3, and we actually have some additional functionality. I think most of you use it, right? Do while, catching errors, string functions. Then we have DOM2 and DOM3. Well, I have it here because, well, you will not be able to read it. It's not even everything. But new objects were actually added, new ways to access existing document object model, which provides for great vulnerability surface. This is what it's all about, right? It's about attackers exploiting the different ways to access the same document object model or browser object model, and attackers relying on the fact that to add all of this standard into a browser, that's just paper, right? It's just a piece of paper describing how browser should behave. It's not a piece of code. Every browser manufacturer, and back then browsers were predominantly closed sourced, had to write it in their browser. And of course they made mistakes. So that's provided for larger vulnerability surface as well. Well, and then going 2 years later to DOM3, we have a lot of other ways to access our DOM. Back to ECMAScript. So this is a fun part. Most of you here have worked at least 5 years. So you probably have noticed this huge gap of 10 years. That's where when a lot of things happened, lots of hacker things happened, because during these 10 years we didn't get any new version of JavaScript. We got DOM level 2, we got DOM level 3, which didn't actually provide any additional security, because language itself, the syntax, the functionality of the language was not touched by that. Only more code was added to the browser and more possibilities for developer or the attacker to connect to different elements. Well, the holy grail back then, during those years, was of course trying to read the local file system. which was quite fun and quite doable. You could do some iframe tricks on, or rather frame tricks on Microsoft Internet Explorer, and then read them with JavaScript. That's because they didn't properly sanitize the same origin part, right? Local file system was considered the same origin as the site, whichever site you're on. Right. So it didn't happen because ECMA. I skipped that a bit. ECMA was kind of a non-governmental institution where a conglomerate, you may say, where different manufacturers like Microsoft, like Google later on, came together and tried to work on the standard. So they started to have competing interests, and actually a whole version was dropped. ECMAScript number 4 never came to be, and it took some time. Well, attackers enjoyed that time, because this is also the time when we saw the first major shift into web applications because of social networks. Social networks were getting super popular, and it was super easy to, yeah, many people did stuff. It was fun. Right, so ECMAScript 4 was skipped. Then we have ECMAScript 5. Anyone uses this construct? Right? Good. Thank you. That's great. That is actually useful. Yes. So strict mode was enabled, which is great. Built-in JSON parsing functions, and we actually finally managed to have some capability to work with arrays in a meaningful fashion, right? And we could also bind the function to have a dynamic variable. We load it, and it executes function just by accessing the variable. So that's one thing attacker could exploit, right? So, and to end this theory part, so WebSockets, I could not have not mentioned WebSockets. It's a completely new technology, right? I guess that some of you may even not need to know how it works, right? You just use different snippets of code, and it just magically works. It works over HTTP still, but it's a completely different protocol, which means for a couple of years, I'd say for 5 years, after 2011, when WebSockets appeared, your security audit tools in your development company didn't do anything with that. So you had to rely on your own qualifications to do it properly. You were auditing your software with automated tools, and everything was great. But WebSocket part was not that good. Right, and then, so after 2009, 6 years later, now ECMAScript, it seems like is going to have a new version every year. They're named just ECMAScript and the year number right now. And they're actually making it into a full-fledged programming language. Well, that ECMAScript is a Turing machine compatible language. It's not a surprise, right? What was the year when the virtual machine were first run in a browser? It was 5 years ago, around that time, right? We can run Linux in a browser, fully in a browser, so that means we can basically run anything on it. I think we can also run Windows, of course. So the fun part, attacks. So these are the things you should think about. Of course, now we have automated tools, even for WebSockets, but well, we do penetration testing a lot. That's when a company comes to us and asks to hack them, and we hack them and give them a report of that's how we hacked your application or hacked your company. But automated tools tend to skip a lot, so we do it manually, and it would be great if you as developers also understood the most common attacks. And since we are doing a retrospective here, I also looked up at when the attacks were fixed. So those are marked by square brackets there. Well, content type misinterpretation. It's quite an obscure one if you don't work in security. So let's say you have a website where you can upload some files, pictures maybe, usually pictures. Maybe you can upload Word documents. But there's this one browser that ignores what your application is telling them about the file type, because extension on the web doesn't matter. It doesn't matter if it's .exe or .html or .block3. It doesn't matter. Content type header matters. But this browser thinks it knows best, so it tries to auto find the content type. So if an attacker can craft, well, not much to craft, right? If it's a text document, you just add HTML tags in there, and the browser will think it's HTML, even though you send specific content type. Then HTML will get executed, you get JavaScript running, and the ball gets rolling, right? So solution appeared in 2008 in Internet Explorer only, of course. You add this header, and it's all great again. This stops. Internet Explorer doesn't try to interpret your content type anymore. Clickjacking. This was a huge thing, and most of the things I'm talking about are fixed these days. And I'm very happy about that. I was frustrated at first when I was trying to hack stuff, but when I try to fix stuff, it's really great to see that these things are fixed. So how clickjacking works is basically the usual method is that attacker lures your user into their own web page and uses a frame element or iframe element to present your web page. And in their parent web page, the attacker's web page, they add some transparent images or some other transparent elements on top of some elements on your web page. And the user thinks they are clicking on something, and actually the click gets taken away from them and passed to your application, and your code gets executed, and user is annoyed and may be confused and may actually type their secret data to the attacker. So X-frame options deny is a thing here. By the way, so I guess I'm not going to ask if some of you know, but because obviously some of you do. There's this X in front of some of the headers. I'm sure some of you know, but I'm sure some of you don't. What X means is it's a non-standard header. It started as a non-standard header that one of the browsers just decided to implement. Some other browsers also implemented with time, but it didn't follow the proper procedure of going through the consensus. And for some, we see this X in the front, so the extra headers. All cross-site scripting, that's quite fun. Two types of cross-site scripting, still a huge issue for front-ends. Now it's moved mostly where? To mobile apps, right? We can get, if you have your mobile app that's based on HTML, then you can actually get cross-site scripting running in the mobile app. And there are two types of cross-site scripting, and I found it so important that I decided to waste your time with this and tell you about two different types. Now for stored, everyone who I talk to understands this immediately, right? So attacker goes to your website. Let's say it's a comment section of an article. They type in some bad code in there. It gets stored in the database. Whomever opens that website, that article, and reads the comment, this gets executed in their browser, in their user session context, which is bad, right? And it's easy. Now, reflected XSS, I usually have to explain this 3 times to some people, to some developers, because it only works for the user who executes it. So only if you yourself open this, then it gets executed in your browser. So you have to directly open that and directly immediately executes. But it's still a huge vulnerability. Why? Because scams, because emails, because instant messages, right? Banks do a good job. They time out your session a lot, right? Social networks, not so much. They want you to stay on the network, so they keep your connection open. Let's say you're logged into some large social network, and the scammer sends you an email saying, well, here's my super nice link, open it up. You click on the link, and this gets loaded in your user's context, meaning that they are the ones executing it, and they are the ones getting the script, the malicious script run in their context of their social network. So it's a huge deal, and was well, we had to rely on developers to actually do code properly up until 3 years ago. Now there is a proper, well, not proper way to do it is fix it in your code, but there's a good mitigation, really solid mitigation now available. Now this is not the solid mitigation. So it appeared in 2010. At first in the Internet Explorer, a couple of years later also in other browsers, they also adopted it. Header X-XSS-Protection, set it to 1, and it uses a built-in blacklist filter. For example, it looks for script tags and then blocks or amends the request that you send. It only works because browser developers update it all the time, right? Because at first they had just a script, then attackers could choose the C letter to be capital C, and it went through. Then they updated it there. Then the attackers said, well, we don't have to use script, we can use what? For example, image on error, right? And then add script there. We can use SVG, very popular right now. So many ways. And it's not a full protection, it's not intended as a full protection. So luckily, 5 years later, the full mitigation came. Once again, the right way to do it is encode the HTML entities in your web application before output. Modern frameworks do that for you, but if you do some magic, you can still mess it up. If you want to do something extra around your framework. So content security policy, again, these headers, of course, are also provided by your frameworks, but they can be toggled on and off. And this specifically needs to be configured and tailor-made to your application. It's quite a complex header. Here's just one example, but it defines where different resources can be loaded from. So it's not only about scripts. You can define where image can be loaded from. Because guess what? Image is also a vector, right? If you have one of those strange applications which has session cookie in the URL, right? When you load an image, it can be given to the attacker as a referrer, and they can still get your user session. So now this old header is part of content security policy, and this is quite effective, but once again, just as a mitigation strategy. Referral attacks, it's quite funny actually that they decided to fix this in 2017, because we haven't seen any real use for these attacks except spying on users. But once again, confidentiality, also important, right? Where you're browsing, what your ad partners know about your users. It's actually not approved yet, it's a draft of 2017, and it talks about how refer can be passed in what circumstances. Once again, it has multiple options. For example, do not send refer at all, or send refer only to the same origin and only the domain name. And there's of course the unsafe URL version as well. So, in conclusion, new features in ECMAScript and DOM levels provide for ever-increasing vulnerability surface. Once again, it was because browser manufacturers have to implement all that paperwork in code. They aren't, of course, given ready-made, validated code. So attackers will find exploits. And these are the most dangerous ones. This is basically the only way to have what's called a drive-by exploit. That is when your user, well, not your user, a user opens a page, and malware, binary malware, operating system level malware gets executed immediately without any user interaction. Nowadays, the only way to do that is have a browser exploit, and they still happen. So it's really dangerous. And second thing, as I mentioned previously, is of course lack of explicit protection. And browsers have done a lot. They have created these headers. One thing I didn't mention, but I'm sure you all know, is of course secure flag on a cookie, HTTP only flag on a cookie, right? If you don't, please look these up. It's super important. The first one doesn't allow the cookie to be transferred over unencrypted session. The second one doesn't allow the cookie to be read via JavaScript at all. So that's a great feature, right? Those of you who have done this for more than 10 years probably remember you could use window.moveTo, right? Now you can't. Even though it's still part of ECMAScript, most browsers have disabled this feature that you can move the window around, because it was super annoying to users. It was great for ads, but it was super annoying. So they are working on that, and they are trying to reduce vulnerability surface, but it's a lot of work. If they didn't do any work, we would be up to here in vulnerabilities. So it's great that they do that. And the race will always continue. Your users will want new features from you. You will be asking browsers to support new features. So it's easier to code, and so you get more functionality so that you can create a more fluid web application. It will increase the vulnerability surface, of course, and that means the attacker will get more opportunity to attack the browser. So thank you very much.
I think we have time for one or maybe two questions even, so. So, wait, no questions? We had 30 minutes of security thing and no questions?
Everyone's scared.
Hello. So, like, this is not about the presentation, but I'm just curious. Like, in your practice, did you ever encounter like something where you thought, like, that are really creative, like a hack or something like that, like an interesting story? Thanks.
It's not creative in a way that it was everywhere after a time, but a client came to us saying that their website behaves strangely. And it was a new attack vector that was malware distributing over web applications. But it was quite clever because it, at the time, because it had a functionality within that didn't give the malware to users who have been on the web page. So it only gave the malware out to users who came directly from Google and who didn't have a cookie set. So we actually did spend some time looking at where the malware is, right? Because a new client comes in, they say, well, we may have a problem. They don't usually give direct access to the server right away. They ask to look around from the outside, and we request it 100 times, and we never get the vulnerability. We never get the malware. So it was quite a tricky case back then. Yeah.
Sorry, we're out of time, but
I'll be around until lunch.
So go and ask interesting questions to Kirils. So thank you again.
Thanks. Oh, thank you.